Okay, let's do this GFG question. Equilibrium point. Given an array ARR of non-negative numbers, the task is to find the first equilibrium point in an array. The equilibrium point in an array is an index such that sum of all elements before that index is the same as sum of elements after it. Note, return equilibrium point in one based indexing, return -1 if no such point exists. So what we have to do here, we need to find a point such that sum of elements of left hand side should be equal to sum of elements of right hand side. And let's see an example. Input ARR 13522. Here we can clearly see that 5 is the equilibrium point, as we have 1 plus 3 which is 4 and 2 plus 2 which is 4. So here 5 is the equilibrium point, and since it is a one based indexing, we have to return 3 instead of 2. Let's see another example. We have a single element in the array, so we will always return 1. Now we have this another example where there is no equilibrium point. So in that case, -1 needs to be returned. You can clearly see in the question. Now the time complexity they expect is big O(n) and auxiliary space is big O(1). Let's see how we can solve this. Now we need to let's just calculate the total sum first of all. So let me take a variable. I will tell you why I took this sum variable. Let's first calculate the total sum. The sum plus ARR I. So this is the total sum. Now one by one we need to check that if that particular sum is actually equal to uh, the remaining sum or not. So let's do that as well. Here we will first accumulate the sum in a sum variable, and before that we need to check that if this particular sum, like sum that has got accumulated up to now, is equal to total sum minus sum and the current elements. So actually it will give the summation of the left elements in the array. So this is trick here, and in that case we will need to return the index, which should be, since it is one based indexing, it should be I plus 1. And in case where there is nothing, we need to return -1. Okay, let's compile it. N was not declared. Okay, let's declare N as well. Since it is a vector array, so array dot size will give us the number of elements. Let's submit it. Okay, it's working. Now, okay, let's see how it worked. So, yeah, let's see the first example, 13522. So, where when I was like 1, I was 0, sum was 0. I'm talking about the second loop, because of course we know that how first loop is done, and then ARR at 0, which is of course 1, right? We have to see that the sum which is calculated up to now, which is 0, 13 is the total sum of this array, and minus the sum which is calculated till now, 0 minus 1, which is the current value. Is 0 equals to 12? No, it's not. Let's move to the I equals to 1. Sum here is 1 because we have got it from the earlier one, and ARR at 1 is 3, so we will check it again. 13 minus current element, 13 minus sum minus current element, and is 1 equals 9? No, it's not. Let's move to I equals to 2. Here sum will be 4, which we got from the earlier accumulated sum, and we will again check because at ARR at 2, 5 is there, so 4 equals 13 minus 4, and then minus 5, which is current element. Is 4 equals to 4? Yes, of course. So return the index. That's how it worked. Thank you.